Hey guys, welcome to day 5 of the CSES Problem Set. Let's just jump straight into it. Trailing zeros. Calculate the number of trailing zeros in the factorial in factorial. The only input line integer n, print the number of trailing zeros. Okay. So n equals int input. What's the best way to do this? Let's pull up Excalidraw. This doesn't seem like that's something that's that hard. It just seems like something that could get complicated because obviously we can count, we can do the factorial and then count, but like it's 10 to the 9, so that's not the right way to do it. We're gonna run out of, not gonna be able to compute that basically. So 20. List 1 through 20. Does this work? What the? Oh, I don't know if I could do that. It's not really what I wanted, but I don't even know how I did that. Wait, what? I just want a list, bruh. Okay, well, let's get rid of these because we do not need these. Let me copy this, paste this because this is what I want. Okay, too big, too big. So zeros, right? 1, 2, 3. Uh, 4. 4 zeros. So it's basically just count number of 5s and count number of zeros, no? If we are at 5, then there's 2, right? How do you do factorials in Python? Oh, whoops. Math factorial dot factorial 5. Five is 1, 0. Right. So 1, 5, 2, 5. Okay, okay. So let me think. It's n to double divide by 10. So if we got 9, we'd be at 0. If we'd be at 19, we'd be at 1. Seal. So it's not double, it's seal. A equals n divided by 10. So 9b1. That's not true though. 19. Mm, okay, instead of 10, 5? 10b2, 9b1, 19b3, 20. Yeah, okay. So it's just, they're not just print. Why does this feel way too easy? Okay. Wrong answer. Hmm. 97. Why does 97... Okay. 50. Times 40. 50 times... Okay, 97... 95 times 94. Still only 1 0. So where are these extra zeros coming from? Like, at what point does it start diverging? I'm so lazy to count this. Just do it in. And then Bro, I'm just doing testing, man. All this for testing. If A negative I okay. Okay, 1 times no, it would just be I. This doesn't matter, but die int not subscriptable. It's over. Class int. I'll just count it, bruh. Must be string, not int. $22. User output 79. Correct output 97. Yeah. Number of trailing zeros. I don't understand. They said 22. Oh, it puts 300. I think I understand now. I think I am piecing out what is going wrong. Although I didn't realize we're missing 4 zeros here. $19. Wait. 99 has 19 zeros of 22. So when do we start losing? Zeros. I don't understand. 4, 20. 20 seems to work fine. 20 is 4. 30. Let's comment this out real quick. 30 is 6. That's to be expected. 40. So 40 should be 8. 50 should be 10. 60 should be 12. 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. 14. 16 gave 14. Wait. 1, 2, 3, 4, 5, 6, 7, 8, 9. 40 gave 9. There should be 8. 1, 2, 3, 4, 5, 6, 7. 30 gave 7. 20 gave 4. 30 gave 1, 2, 4, 5, 6. 30 gave 7. Why did 30 give 7? Seven. 1, 2, 3, 4, 5, 6. It's because this can turn into 2 zeros. 25 can turn into 100. Okay, so which ones can turn into multiple zeros? Here's 25. It's for the hundreds case. So okay, so this is because 25 is two fives, right? 25 is technically 5 times 5, so you get an extra 0 out of this. Next time you get that is at 50. 50 is 10 times 5, so you get an extra 0. And then 75. Okay, so at 50, in theory, you should have 10, 11, 12. 12 zeros. 1, 2, 3, 4, 5, 6. Okay, I'm not doing this. 12, yes. Now 75 would be the next breakpoint. Okay, 75 is 18? Oh yeah, it's plus 3. Yes, that makes sense. So for every 100, there's an extra... Okay, 100 should be 10 times 5, so 1 extra 0. So 100 24, yes. So every 100, there's 4 extra zeros. Basically, every multiple of 25, there's an extra 5. But then some multiples have... Okay, so like 1000 is... Okay, 100 is 10 times 5 times 2. 1000 is 10 times 10 times... Huh? 2 10, which is 3 5s. So basically, we're just counting the number of 5s. This is 2 5s. So this is 3 5s. So how can we handle this? Okay, so the first instance is at 25. Hmm. 25. Special about 25. Well, it's 5 times 5. Hmm. How much is 25? It should be 1, 2, 3, 4, 5, 6. 25. 5. 5. Hmm. So, okay, so this counts all the multiples of 5. Now we need to count all the multiples of 25. And then we need to count multiples of 25 times 5, which is 125, etc., etc. So it's the sum of n I equals 1 to basically infinity. Now, what's the cap? Okay, say we have 100. Then our cap is 25. What's the count for 100 again? $24. There's 25s. 25s plus 4 extra. So the next number would be 125. 125 divided by 5 is 25. There's 25 numbers that have at least one 5 in it. Out of these 25 numbers, how many have at least two 5s in it? there are 2 5s, 25, 50, 75, 100 that have, okay, you just have 1 5. So dividing, we counted out the 1 5s. This is how many have at least 1 5. Uh, 25. 1, 2, 3, 4, 5 is 5 that have 2 5 and then 1 that has 3 5s. So okay, 625 is next. One 5. There's 125 that have 1 5. That have 2 5s. 5. 20. There's 25 of them that have 2 5s. Has 3 5s. 5 of them has 4 5s. 1 of them. Okay, so it's just 5 to the n. Except this is our n. It's 5 to the... Our n... It equals 5 to the some power. So what power of 5 can divide into n without being too much, basically? Well, this is basically dividing by 5 each time. So if we had like... This is supposed to be a 5, by the way. If we had 626 divided by 5, 626 double divided by 5 is still equal to 125. Oh, okay, wait. So this should be pretty straightforward. Let's keep import in. For okay, so what's the process like? It's n divided by 5. 24. If it was 100. If it was 25, be 25, 5, 1. Never tested case 25. There should be 6. Yes. So it's 5 plus, it's these. 24. Uh, 100 is 24. 26 divided by 5. 5 1 should be 50 divided by 5. 10 divided by 5, 2. Wait, what's 49 divided by 5? Is 5. Is 9. Oh. 9 divided by 5. 9 divided by 5 is 1. Which is 10. Okay. So it's the sum of these. So count all zeros. Plus 0. And it's n divided by 5. And then zeros plus equals n. While n (48) is 9, 1. 44 is 8, 1. 76 is 15, 3. While n is greater than or equal to 5, divide n by 5 and add to zeros. 76 greater than 76 divided by 5 is 15. Fifteen is greater than 5. 3. Okay. Okay, that worked. Yeah, this should work then. Yeah. Okay. That took a while. 47-minute problem. I didn't think it was going to be that difficult, but number of trailing zeros in a number equals the numbers times we can divide by 10. Since 10 equals 2 and 5, we can focus on factors of 2 and 5 in the factorial. Number of 5s is always smaller than number of 2s, yeah. So we focus on the number of 5s. The number of trailing zeros equals the number of factors of 5, so yes. The following code calculates the number of factors of 5 by dividing in by 5, 25, 125. I don't get it. So, oh, yeah, wait, that's exactly what they do, actually. Yeah, this is like the same code. Okay, good to know. Well, we were able to do it. This was a pretty difficult question, actually. It was just knowing the pattern. Was it difficult? It shouldn't have been that difficult. But then again, I feel like for all of these CSES questions, it feels like they aren't that difficult. You just need to see the pattern, you know what I mean? It's like, okay, for this one, even after I saw the pattern, I had to like question a little bit of how to implement it. Right. Like, I had to trial and error a little bit. Basically, the first time we divide by 5. Okay, I'm still a little... I don't understand why this exactly works. Because, like, I get... It's like I get it, but I don't really get it, you know? Because we set 5... Okay, so we start with our number. Do 50. 50 divided by 5 is 10. So there are 10 numbers that are a multiple of 5. Okay, it works because the next pass is technically doing n divided by 25, which is 2. Yeah. So for a broader case like 76, we check how many numbers are divisible by 5, which is 15. And then we check how many numbers are divisible by 25, which is out of the numbers divisible by 5, how many of those are divisible by 5, which is 3. Because 15 already includes the numbers that that are divisible by 5. Yes. Okay, I get it. Alright. If y'all like this video, be sure to like and subscribe, and I'll see y'all tomorrow. Bye.